Yes. My presentation will focus on the combination of chemical and electrochemical sensors for mimicking the odors and flowers for food. It is entitled Geographical Classification of Virgin Olive Oils of different regions of Morocco. The plan adopted in my presentation was structured as follows. I begin with an introduction in which I describe the different points. Shortly after, I will present the experimental setup, which include the electronic tongue and the electronic nose. Then I will describe the pattern recognition methods that have been used for the data analysis of the electronic nose and the electronic tongue. After that, I will continue on the experimental results and discussion. Finally, I ended my presentation with the conclusion. As an introduction, I can see that virgin olive oil is a relatively new international product that nowadays is exported by Morocco to different countries in Europe and North America. Due to its much higher market price, there is always the possibility of illegal practice such as dilution with cheaper oils. The detection of aroma volatile compound emitted by virgin olive oil is of key importance in the quality control of these products. Several classification methods such as GC or GC coupled with MS or HPLC have been used for this purpose. These traditional analytical methods are expensive, time-consuming, and do not allow online measurement. What is the alternative? Actually, this disadvantage has been till now overcome by the use of an electronic nose and an electronic tongue combined with a pattern recognition techniques. These ones offer a fast, simple, and efficient tool for classification purpose. In several applications, the combinational approach of sensory systems such as electronic nose and tongue have demonstrated improvement when compared to individual systems. The question now is, what is an electronic nose? The term electronic nose refers an instrument which combines both an array of electronic chemical sensors with partial specificity and an appropriate pattern recognition system capable of recognizing simple or complex odors. The principle of electronic nose is the transfer of the total heat space containing different chemical volatile compounds to a sensor array where each sensor has partial specificity to a wide range of aroma molecules. What is an electronic tongue? The electronic tongue is an instrument that measures and compares tastes. The principle of the electronic tongue is similar to that of the electronic nose, except for the array of sensors which is designed for liquids. The aim of this study is twofold. On the one hand, it seeks to classify 5 virgin olive oils picked up from 5 Moroccan geographical areas by combining an electronic nose and tongue. On the other hand, to establish the classification of Moroccan geographical VOOs by using an improvement data fusion technique coupled to PCA and SVM pattern recognition methods. This slide shows the prototype of the electronic nose used for the experimental setup, which home fabricated for food and beverage aroma purposes. The sensor array used is composed of 5 heated metal oxide gas sensor, the type Figaro TGS 800XX with XX equal 15, 22, 24, 25, and 42. We used also a temperature sensor and a relative humidity sensor. For the electronic nose experimental setup, we used 5 virgin olive oil picked from different regions. 5 replicate measurements were performed for each VOOs variety. For the electronic tongue experimental setup, we used a cyclic voltammetry, which consists of a conventional 3 electrodes potentiostat connected to 3 electrodes that get immersed into a solution. For the electronic tongue measurement, we used a voltammetric measurement on VOC, which thermostatically controlled using a water bath of about 13 degrees C at 10 minutes. The range of varying potential is chosen between -700 to 1700 millivolts with a scanning rate of 100 millivolts second minus-minus. This slide describes the pattern recognition methods that which have used for the electronic nose and electronic tongue data. These multivariable techniques are divided in 2 families, supervised and unsupervised techniques. The supervised methods are linear, can be linear or non-linear. For example, KNN and LDA are linear supervised method. PCA and CA are linear unsupervised method. Regarding the non-linear methods, we can find ANN, SVM, and SOM. In this slide, we describe different type of improved data which can be used for the treatment of data fusion from electronic nose and electronic tongue. In this study, we use the low level of abstraction. When data fusion of electronic nose and electronic tongue were performed. ANOVA variable selection were performed to do data set in order to build an improved low level of abstraction data fusion. This slide describes the evolution of the signals generated by the TGS 825 sensors for measuring the volatile gases. As can be seen here, during the first interval of time, the conductivity is very low, and after the conductivity increase rapidly and stabilize at 10 minutes of exposition. This slide shows the filter used for the data analysis which are extracted from the response of the electronic nose. 5 filters were extracted: G0, G0, GS, GG/DT, and the area S. There are 20 variables which are described by each measurement. 20 because we have 5 sensors and 4 filters. This slide describes the evolution of the voltammetric response. As you can see, excuse me, it can be seen that this figure response vary. Excuse me. As it can be drawn in this figure, clear response variability was observed in the cyclic voltammogram response of the tongue. Other cyclic voltammetric were recording using the 3 others electrode, such as gold, carbon, galaxy carbon, and lithium. This slide shows the filter which are extracted from the cyclic voltammogram.
Excuse me, this is almost time, so please finish quickly.
Okay. There is 5 filters which are extracted from this voltammogram cyclic. This slide shows that 2-dimensional PC upload performed on 5 VOC measurements gathered using the electronic tongue data. The total variance explained by the first 2 principal components is 76.62%. Nuclear differentiation could be made on oil 2, 3, and 4. This slide shows this 2-dimensional PCA performed on 5 VOC measurements gathered using the electronic nose data. The total variance is 19.19%. A clear obvious discrimination is found between the tested sample excepted for while 4 and while 5. This slide shows the PCA plot performed on 5 VOC measurement gathered using the improvement low level of obstruction data fusion. The variance explained by the first two principal components is 19.10%. As one can plainly see, the two PCA axes contribute potentially in separation between the all studied VOC. I pass to the conclusion. This, I can see that neither electronic nose nor electronic tongue was able to distinguish between all the tested VOC samples. When performing a NOVA variable selection to the low level of abstraction data fusion, it was possible to separate among cluster of different VOOs. Finally, according to these results, the idea of combining the electronic nose with the electronic tongue appears to a complementarity tool in the characterization of olive sample in the routine analysis. And I think this work was done with the collaboration with the different universities of Rovira Virgili and Claude Bernard, France, and Monastir in Tunisia and Morocco. Thank you very much for the time.